Hello, everyone, and welcome. I'm your host for this webinar, Allan Jude. Thank you for joining us live or watching the recording later. For those of you who are new to Klara, we're a team of open source experts specializing in ZFS and FreeBSD. We help organizations design, build, and operate high-performance infrastructure with full control and transparency. You should reach out and talk to us if you are designing or re-architecting your storage platform with ZFS, you need to improve the performance, reliability, or operational efficiency of your infrastructure, or you want to build open source solutions that avoid vendor lock-in and support long-term sustainability. Before we dive in today, just a quick note about Klara's ZFS storage design service. If you're building or evolving your storage platform, especially environments with strict compliance, security, or sovereignty requirements, Klara can help you design platforms that are resilient, performant, and operationally sustainable from day one. That includes configuration validation, tuning and performance, and making sure your design will hold up not just after deployment, but years into its full life cycle. We'll share more details on this later in the webinar. But on to today's topic, why EU companies are choosing ZFS for tech sovereignty. We'll be talking about how organizations can maintain control of their data, infrastructure, and operations without relying on proprietary platforms or restrictive vendor ecosystems. As we'll highlight as we go through the session, this comes down to making deliberate architectural choices, choosing where data will live, who will have access to it, and how the system will evolve over time. So we'll be talking today and taking a practical look at why Entersekt selected ZFS as its EU sovereign storage platform, how open source storage enables control, compliance, and transparency, and some key architectural decisions and trade-offs. We have a Q&A session open in Zoom, so go ahead and ask your questions as we go, and we will answer those throughout, and we have some time at the end to cover even more. But most importantly today, joining me is Eirik Øverby, Director of Technology Operations at Entersekt. Go ahead and introduce yourself, Eirik.
Yeah, hello everyone. I'm Eirik. I have been working with FreeBSD and ZFS stuff since the early 2000s. Been an early adopter of ZFS, and that has turned out to be a surprisingly smart decision. I think smarter than I was at the time. So it supports us very well right now. So I look forward to this webinar.
Yeah. So to quickly summarize what we'll go through today, we'll spend a few minutes talking about why ZFS and what the advantages are for those that aren't familiar. But then we'll get straight into, when building a sovereign tech system, what are the factors that make it work and what are the factors that don't? And then we'll also talk about some real world outcomes and impacts with evidence from Entersekt about what worked for them. And then we'll summarize everything and answer some questions. So jumping straight into it, ZFS, the open source storage platform. One of the biggest advantages to ZFS over a traditional file system is the fact that it's copy on write. So that means whenever you're updating a file, instead of overwriting the old version in place, ZFS writes the changes to a different place on disk and then updates its index to point to that new place. The advantage of this is if the power goes out in the middle of that write, while you were saving a file, in a traditional file system, you will have a corrupted file now because the first half of the file will be the new version, but the second half of the file will be the old version because the power went out in the middle of writing. With ZFS, you will either have the complete old version or the complete new version, never some mix of the two that is corrupt. It also means that when the system comes back up, it doesn't have to do any kind of scan or checking. The file system is ready to go right away. And when you have hundreds of terabytes of storage or more, that can be a big advantage of being able to get back up and operational right away rather than have to wait for an integrity check. But speaking of integrity, one of the other stronger advantages of ZFS is the end-to-end checksumming. All data written to ZFS is stored with a checksum as well, so ZFS can verify when it reads it back that the data hasn't been changed, making sure that a flip bit when you were writing, or a bad cable, or a hard drive that just lost a sector, or an NVMe drive where the flash is worn out and giving back garbled data can all be detected and repaired by ZFS using its end-to-end checksums. And one of the other big advantages of ZFS is pooled storage. When you have to combine a whole bunch of storage devices into one big pool, you get the advantage of not having storage silos. In the past, if you had a bunch of separate devices, they might be, a different file system each, and that might mean you'd have some free space in each of those, but the new data you were trying to deploy was bigger than the free space in any one of the silos, but smaller than the sum of that free space, but you couldn't use the sum of the free space because they were separate storage stacks. But with pooled storage, all of your data is together, and it means all of your free space is available. And so you can create that new file system and deploy your data to it and have access to all of the storage capacity that you have across the different devices. ZFS also allows policy-driven configuration, so you can divide your data up into data sets and have different policies and settings for each one. So your database can have small records to lower amplification, while your logs have big records to get more throughput. Or when you're video editing, you have very large data sets for performance and throughput, and different data sets for other data. And then one of the biggest advantages of ZFS is its replication system. You can back ZFS up over the ZFS protocol and get recovery point objectives down into the minutes. With traditional backups, it would take hours to take a backup, and so you couldn't have a recovery point that was better than like 12 hours. But with ZFS, 12 minutes is realistically achievable, and that is a very big difference when you're talking about recovering from an event. So getting straight into what works for building an independent and sovereign system. And when we're building a long-term strategy, the first thing we have to decide is which objectives for independence are the most important to you. Are you worried about transparency or jurisdiction or control or what? Which thing is going to make the biggest difference for you? Because that will impact a lot of the following decisions. And you don't want to let the vendor dictate your platform lifecycle. When we're looking at this, choosing your platform, one of the biggest things is transparency. Can the code be inspected and audited? Do you have access to it? And then you have longevity. Will the platform remain available independent of a single vendor, right? What if your vendor goes out of business? Are you still going to be able to access and service your storage? And then portability. Can you move your storage between platforms, right? What if you change hardware or providers? Will you be able to have the same storage in a different place? And then there's operational control. If you are giving this to someone else to manage, if you have a support vendor, it should be well understood and a reasonable decision. You've decided why you're doing that and that you trust the controls they have in place. But do you understand why you're giving away some of the control? And what are the advantages of that? And more importantly, does your license with your storage platform allow you to do that? Some storage platforms require that you not use any outside support. You can only have your team and the vendor support and nothing else. And that's another way of locking you in even further. But when it comes to sovereignty, the biggest issue is always jurisdiction. What jurisdictions have access to your data or can compel access to your data? And I know this is a big concern for you, Eirik.
Yeah, very much. There are many things I could say about why we chose and why we use ZFS, but it has become a big deal. One of the things that ZFS can allow us to do is what you said about the replication and backups based on that, combined with the encryption, which remains under our control. We can still conceivably push data outside of our jurisdiction, but still not lose control of it. So we can use third parties, let's say for long-term storage or for other purposes, and not worry about the actual integrity and secrecy of the data itself. And that's something we can do without losing operational flexibility because of being able to maintain the data, etc., without anyone else needing to look at it. Jurisdiction over data stored physically in Europe is still a very complicated thing, because it depends whoever controls your data. So even if you have a large cloud vendor or something that has data centers in Europe, it doesn't necessarily mean that the jurisdiction over that data is exclusively European. So that is something we worry a lot about. And as you will mention later on as well, that's part of the reason we're sticking to our own data centers, at least our own physical storage for the time being.
Yeah, jurisdiction, especially with cloud vendors, can be complicated because it's not just physically where the data center is, but it's, what other governments have leverage over the cloud company and could compel them to turn over your data. So yeah, as Eirik just alluded to, one of the biggest ways to maintain control of your infrastructure is to physically control it, to either have your hardware on premises or in a trusted data center. And when you own the hardware and have physical possession of it, it makes it much easier to control who else has access to this. And Eirik, you've also talked about a dual authorization model for physical access.
Yeah, we have. I guess I should have said something before, but my main line of business, so to speak, my day job is to build and maintain systems that handle payment transactions or authentication transactions in the billions per year, which is of course subject to a lot of scrutiny by both national and regional authorities and industry authorities in the payment industry. So we need to build, our systems need to be secure, we need to have physical security and all these things. Being able to tell a client or an authority that, look, that's where the data sits. That's physically where you can come and have a look at where your data sits. That is, at least to a lot of European clients, if at least it's important to them, and for some of them it's an absolute requirement. And then the whole dual control, as we call it, basically making sure that nobody can, open the rack, access the hardware on their own. It can sound a bit complex, but it's actually fairly easy to implement, and it ticks so many boxes from a security perspective. It raises the bar so much for, having a rogue sysadmin or any other kind of situation where it's hard to vouch for what is being done, what has been done, etc., because you'll always have multiple witnesses to the events.
Yeah, that can be a big part of maintaining security, is making sure that no one person can do something without other people being involved.
Precisely.
And then another key part of having a sovereign and independent architecture is open source. The fact that you're not relying on any proprietary management tools, you don't have restrictive licenses or vendor specific APIs, and you have access to the source code to modify or review or whatever yourself, gives you a lot more control and the kind of longevity. It's something that can't be taken away from you. Once you have the code, you have the code. Something might change with the project upstream later, but you can always go back to the version that you have right now and maintain that.
This is another thing that is super important to us. I'll admit that part of the reason that our entire stack, everything from our routers and firewalls all the way to application and database servers and everything is open source and everything is FreeBSD based. There's an element of idealism in that. Obviously, it's choices that I and my team have made throughout the years because we like it, because it's nice to work with, etc. But there are these other benefits, like when certain key value store vendor decided to enshitify their license, and before we even had time to start looking, there were several forks that were not only under an agreeable license, but many of them were even far better than the original software. And we could just swap it out because we have no ties to any vendors. We don't have any ties to any specific packaging of the software or the platform we run or anything. We can just take that element out or replace it with something else, and it just keeps on going. It's happened to us a few times over the last years, especially, and I feel like it's accelerated with the whole enshrification wave that is going on, and that has helped a lot. Now, we don't mind spending money on open source software, but we want to know where that money is going. It's a bit like if you pay taxes, it's nice to see where it goes, right? It's nice to see how it's spent. Now, if we throw a bunch of money at a large company that provides us a little bit of software and a lot of paperwork, that doesn't feel meaningful. But if we throw money at either an individual developer or a project or an organization that works very closely with the open source projects that we use and depend on, that feels a lot better. And it feels like the money is actually put to work in a way that helps not just us, but everyone else as well.
Yeah, and that key element of transparency there is a big part of it. You being able to see what's happening both in your infrastructure, but also kind of in the project upstream is something that open source tends to excel at. So we have a live question from Rain who asks, how do you balance the need for multiple people to access important infrastructure versus incident response? It's 3 a.m. and there's only one person awake.
There's a difference between the physical access and the logical access. Logical access is much easier to track and trace and keep a record of than physical access. So luckily, I don't know, in the last 10 years we've had to go to the data center maybe once or twice in the middle of the night, that sort of event. And then we do have a on-call schedule and everything, so that usually works out, but the vast majority of the work we do can be done remote. And then you have other ways of being able to observe or check later what that person has done if you need to do so. So of course, if we were in the kind of business where everything had to be done physically on site, then this company wouldn't exist, because in the first few years of our operation, we were exactly 2 people. So we've grown a little bit since then, which makes things a lot easier, of course. But yeah, good, well-controlled remote access helps a lot. And of course, out-of-band management.
Yeah, but in the end, the answer is if you have to wake a second person up, you have to wake a second person up.
Exactly.
And then, as Eirik alluded to a few minutes ago, one of the key things is maintaining ownership and control of your cryptographic keys. As Eirik said, this can allow you to do things like leverage third-party storage or cloud storage vendors. If you need to archive stuff, you have compliance requirements, you have to keep this data from 6 years ago for another year or two, or even more. Maybe you don't want to do that on-prem, but you need to do it encrypted with keys you control so that the vendor you're turning it over to has no access to it. And then, all the jurisdictional issues kind of go away if the only way to read that data is with the keys that you control and you maintain sovereignty over.
There's another element to that may be lost when you talk about external parties, third parties, etc. Even internally, it means we can have, let's say, our big fat backup server can sit in a lower security network zone and receive backups from the high security zone, because it has no access to the keys, so it doesn't matter what data is stored there. The transfer of the data is secure because it's over encrypted channels and strong authentication and everything. But even that doesn't matter if the source data and data set is already encrypted, because then it's just background noise that we happen to store on some spinning Rust somewhere. And so even if we want to keep our backups, etc., in-house on cheaper storage in a cheaper physical access setting, like single control, right? Different room in the data center, what have you, then that is entirely possible. And we can still do incremental backups despite the backup server not having a clue what the data actually is. So that is absolutely fantastic.
Yeah, it's one of the really interesting things about the way encryption in ZFS works is, most of the value from encrypting your storage is what's called encryption at rest. So when the machine's not using the data, which, for self-encrypting drives or most full drive encryption supported by, an OS like Windows or Linux, that means only when the machine's powered off. And how often is your production machine powered off?
Mhm.
Uh, with ZFS encryption, you can have different keys for different data sets, and you can unload the key for a data set when you're not using it, right? If you have archival data or like reports, and you only run them once a month, you can have that data set, have the key unloaded, and be at rest, even though the machine's running the, 90% of the time, and only have it mounted when you're actually using it. And this increases the confidentiality of that data. And as Eric said, the backup can just never have the key. So it has all this encrypted data and never has access to the keys for it because it receives it encrypted and it can restore it encrypted and it never needs the key. And an important part of that is ZFS can do its maintenance operations. The scrub or resilver, replacing a failed disk, can all happen without access to the encryption keys. And that means that you can maintain all this data in a way where you don't need to expose the encryption keys beyond, actually accessing the data.
I'd also say one last thing, which is probably of lesser importance, but it means you spend less time at the data center every time you need to replace a drive, because it only actually needs to duplicate when you replace a drive and mirror only the data that you actually have, not the entire drive.
Mm-hmm.
Which is also very nice, because if you only have a 10% fill rate, it's nice to not have to stand around for the next 90% to also synchronize when you replace something.
Yeah, copying all those zeros for no reason.
Mm-hmm.
And then the last thing to consider when you're trying to build a controllable infrastructure is your migration and exit strategy. Whenever you're designing your current platform, you need to think about when it's time for this platform to retire and we're moving to the next platform. Whether that's just a hardware refresh and we're going to keep using the same software, or we might consider a different vendor then because the license renewal, whatever. You need to have a strategy or how you're going to move your data to the next thing. And ZFS provides a lot of tools for this, including its replication or the fact that the pool itself is portable and can just move. But it's something you have to plan for from the beginning. So it seems odd to think about how we're going to get off this storage system when you're designing the storage system and haven't even moved on to it yet. But that planning is the thing that's going to pay off down the road to make sure that it's easy for you to migrate to the next thing, even if it's just a hardware refresh.
We have data sets on our production systems that were born during the beta stages of FreeBSD 7, because that's when we started using this in production even. And some of those data sets have survived until now. New hardware, I don't know how many times we replaced the hardware, probably not enough according to some, but it's still with us, and that's very nice.
Yeah, the fact that you haven't had to re-platform your data for almost 20 years now really speaks to how much longevity you get from this, but also the fact that you were able to migrate it across all these systems without having to do a lot of manual work or conversions. So yeah, digging a bit deeper on especially the value of the transparency of the software stack. The first thing is, with open source software, you can ensure the software is not sending telemetry to some entity you didn't want to, or it's not sending your data or anything else back to some other source, and that each bit of functionality in that software does what it's supposed to do, nothing more and nothing less. The ability to audit the code or pay someone to audit the code and be able to verify that this is what's going to happen when I run this command or click this button, and that there's nothing else happening in this software is a level of control and transparency you just can't get with proprietary software.
It is also extremely helpful when trying to debug problems. So as
Exactly.
you know, Allan, that we've been digging through source code on many occasions to find issues that we've had, and I don't know how we would ever have been able to bring those issues to anyone's attention from certain commercial vendors.
For sure. A big part of that is a system that's observable, where you can actually see what's happening inside and understand why it's doing what it's doing, even if it's not the right thing. By understanding why it's doing that, you can then, it's open source. You can change it and make it do the thing you want it to do. Uh, but with a vendor, you have a black box with a sticker on it that says no user serviceable parts inside. And that's about the amount of observability you get. And then, repairability is kind of right out. Whereas, again, with open source, you have the ability to look inside, maintain it, repair it, or whatever without needing acquiescence from a vendor or, that's not forthcoming most of the time anyway. But like you talked about with your example with the key value store, you also get a long-term sustainability through a community. Software is more sustainable and has more longevity when it's maintained by people who have a shared interest, the functionality of the software and using it, rather than just their own commercial agenda. If a vendor goes out of business or decides to shift their business to something different or, try to force a cloud version of their product, um, you're kind of stuck if you're with a vendor. But with open source, even if the original author or supporting company goes away, there's a community of other people like you who are using this software and need it for their production. And that kind of gives you that safety in numbers and the ability to kind of coalesce around that community and keep the software going. And as you said, oftentimes it ends up with even better software than the original software. So moving on to operational independence. The big part of this is the fact that you're able to maintain your system without a vendor, that you can fix things, change things, support yourself, and recover your storage. If something goes wrong and you need to get your data back, can you do that without the vendor? Because what if the vendor goes away? What if the vendor just decides they don't want to support the version of the software you're using? There's a lot of ways that the vendor can end up leaving you out in the cold. Whereas with something that you control and you can maintain and you can restore without the vendor, then you know that you're not dependent on someone else to be able to perform these critical operations.
I can say something about that. I sleep better at night because I have people I can call if our Galera cluster falls over, and people I can reach if we lose a Z pool or something goes wrong. We pay for support services from, for example, MariaDB. We pay them even a fair amount of money, but again, it's the taxes, right? I know a little bit about where that money is going. Been able to tell them that, well, I really, really don't want your enterprise services, so please don't spend money on that. And the feedback is good, and the support they provide is very good. But it doesn't mean I depend on them. They are a support. They are another leg to stand on. But if they stop being nice, I'm sure there are other people out there who will be happy to be my backup if something happens, if I need support at 3 a.m. So being able to swap out those parties that we pay to help us without having to swap the software in the process or the platform in the process, that is also a huge amount of freedom that it gives us.
Exactly. Being able to choose your support provider instead of being stuck with the vendor and only the vendor and nobody but the vendor.
Yeah.
It really gives you a lot of freedom there. And I think that's one of the most common misconceptions about open source is that, that support isn't there somewhere. And, especially with ZFS and some of the other things we talked about, it is. And, that's Klara provides that support for ZFS for many big enterprises specifically, like you said, so that they can sleep at night knowing if something happens, they have the experts they can call and get it fixed, and they're not on their own. And that's available for almost all open source software. And so, designing with that in mind, and like you said, that freedom to choose who you're going to get support from or be able to change it if situation changes is really a big part of the freedom and independence of a good platform. The fact that you don't have to change your software just to be able to change your support. And importantly, you want to avoid any kind of restricted migration path. If you have to jump through hoops to get out of a platform, it's not a good platform. How are you going to get out and avoid being locked in with your vendor and be able to go on to the next thing? So, you want to change your support vendor, but the migration path is restricted for some reason, then you're not in a good place. So now talking a little bit about the problems you can run into when you don't design an independent platform. One of the biggest ones is vendor lock-in, right? If you have a certain storage platform and the vendor does things to try to keep you stuck in that platform. And one of the biggest one of those is closed management tools. If you don't have access to the management tools, or they're dependent on a subscription or a license from the vendor, that means that you can't operate your system without that vendor. And especially even in hardware, we can see this where the application to manage the disk controller or to replace hard drives can be this lockdown software that's only available on some platforms, and you don't get the freedom to switch to whatever operating system you want because the tools are only available for one or two operating systems, or even one or two versions of the operating system you want, right? You can't choose whatever distro you want. They support this one old distro, and if you use anything else, then you're out of luck. And that can cause all kinds of grief. But also, if the backup or file formats are proprietary, then it means, sure, it offers this amazing dedupe or whatever, but if you can't get the data out, then it's basically encrypted with the vendor's key. It's just not encrypted. It's just in a proprietary format. Uh, you know, if the format is closed, your deduplicated data itself becomes proprietary to the vendor. It's not your data anymore. It's theirs. It can't be exported. It can't be rebuilt. It can't be read without the vendor. And if you're depending on that vendor is going to know it, and they're going to, extract their pound of flesh. And that's why you run into problems with licensing and the renewal surprise. The license was reasonable now, but as Eirik talked about with, the continuous enshittification of the service industry and, the fact that every time a rule comes up, there's some new surprise, you're going to be looking at another set of problems, especially when you look at storage that is licensed per petabyte or per terabyte. You're still, and oftentimes, even with those licenses, you're paying for the logical data. So even though you got some advantage from compression, you still have to license for the amount of logical data, not the amount of physical data. And then how much is that license going to go up next term?
I can attest to this and say that the only time we ever had licensing problems, it was with our own in-house proprietary software that is under a licensing scheme, and suddenly we didn't have a license to run it in our own production anymore. That was great fun. So I'm glad we never have that with the other software we use.
Yeah. And then the last part is anything that's non-portable, right? One of the really nice things about ZFS is you can use whatever storage hardware you want, right? Do you want hard drives, NVMe, whatever, and you can get those devices from whatever vendor you want. You're not stuck using, only Western Digital drives will fit in this chassis or something. And it's hardware platform agnostic. The fact that ZFS is by Endian and supports, x86, 64, ARM 64, you can run it on Power and RISC, whatever platform you happen to choose, or whatever platform might come next, ZFS will be there. And it's available for every major operating system. It's only pre-production quality, but you can run ZFS on Windows if you want to. And the fact that means that if you just need to get that data back off that array and that's all you have available, the fact that you can do that is like how many other storage systems offer that portability to run on whatever hardware, whatever Endianness, whatever operating system, and make sure that no matter what, you'll be able to access your data. And, that also can really help with that sleep at night factor. Some of the other common pitfalls we see are when people just kind of cobble together a selection of mismatched open source software and call it a platform. To be a platform, it's more than that. It's not just the sum of the parts. It's the interoperability and the feature synergies that make a platform successful. Open source is an important ingredient, but you need to purposely design it to make it into an independent platform. If you're locked into your hardware, your platform and your data are at risk. We are actually currently working with a number of large organizations that bought these expensive storage accelerators that promise to make their NVMe storage super fast. But now the vendor's gone out of business and they can't get support for the hardware. They can't replace failed components, and they're in the middle of having to replatform their data because the vendor disappeared. And so, they're learning this lesson and are deciding, hey, we need something that's not going to make us replatform our data if we want to switch vendors or, be able to buy whatever components happen to be the right price when we're shopping. And the biggest mistake a lot of people make is assuming their current platform will just last forever. Hardware will only last so long. You can get 5 or 7 years out of most hardware pretty easily now. But eventually, you are going to have to replace it. And so you want to be planning from the beginning what those steps are going to look like, right? Are we just going to replace the media eventually, and then we'll be able to just pull that media out and put it in new hardware to replace the core of the hardware? What is your steps going to be? And that's something we can help you plan if you need help with that. But now let's move on to the exciting part, because I think there's some questions in the chat that kind of relate to this. What is the real world impact of using ZFS as your independent storage platform? Erik's got a great example with their database.
Yeah, so we run, against many people's advice, we run very large MariaDB/Galera clusters on ZFS. Been told many times since we started doing this back in 2008 or thereabouts, that one should not do these things because this is not performance storage for a database. You'll have multiple levels of caching, etc., etc. But some of the things that ZFS gives us just easily offsets any downside it might have. And I say might because I even questioned many of them. We're getting 3 to 4 times compression ratio on our database cluster, which is significantly more than we would get by using native encryption in the database, because we luckily are in a situation we store mostly transactional data, which means we can afford to use larger blocks on disk than what the database itself would use, which means we get good compression ratio, we still get good performance, and with the current data set we have roughly or a bit north of 1 petabyte of raw NVMe storage across our entire production infrastructure. The price of that, if we would have to store it uncompressed or with worse compression, I don't even want to think about those numbers. I know Allan did, but that's just entirely prohibitive. This is one of the things that makes it easy for me in a large enterprise, large-ish enterprise, where much of the focus is on using cloud for providing much the same services, to justify that, well, we have this on-prem service here in Europe, customers like it, we like it, I like working with it, and also it's not as expensive as it otherwise might be. So ZFS for databases with compression and all the other goodies, I could talk about snapshots all day long. That's really fantastic.
Yeah. So kind of breaking Erik's example down, if we have, just consider a dual parity NVMe array, and we'll assume a 3.5 to 1 compression ratio, and the fact that, NVMe drives today cost between $200 and $300 per terabyte of raw storage. And knowing that, building an array out of that, you're going to need parity and spares and so on. Each petabyte of storage you save using compression can basically save you between $300,000 and $450,000. And so storing a database that, with no compression at all would take over 3 petabytes of raw storage to store. With compression, it's only taking maybe 600 terabytes, but with parity and spares and everything else means having to buy a petabyte worth of flash. Now we're saving 2 petabytes of flash that we wouldn't have to buy. And that's, at today's prices, like $750,000 in savings. That leaves a lot of room for more systems and backups and everything else that goes into running, these critical operations. And then if you consider the same thing, but you're using mirrors instead of RAID Z, then you're looking at saving over $500,000 per petabyte.
Oh, but we are using mirrors.
Yeah. So,
So
so yeah, you're easily looking at a savings of $1 million just from the compression.
yes, yes,
And that same thing can apply to the cloud. If you are having to use the cloud for one reason or other, deciding to use the cloud, using the same ZFS compression on top of your EBS volumes or whatever can provide the same savings. We've had people reach out to us like when I added the Z standard compression support into ZFS. One of these companies that was using the cloud reached out. It's like, yeah, that one little change you did saves us $200,000 a month in cloud storage bills. I'm like, you should maybe consider storage that's not so expensive for this. But for them, that was a big advantage, really. So live, someone asked, why do you use mirrors rather than RAID Z?
we used RAID Z at a point. I feel like mirrors are a bit more flexible. The performance is also better, at least in our case. At one point we just made this decision. I don't want to make things more complicated than it has to be. So let's just go for mirrors. It's, at least in my head, it's easily predictable, both in terms of performance and capacity.
Yeah,
So
I would say, definitely more IOPS from mirrors.
yeah,
Easier to expand 2 drives at a time rather than a lot more, especially with
yeah,
NVMe and the number of zeros in these prices we were just talking about.
yeah,
But yeah, also the predictability. With mirrors, it's always very straightforward. With RAID Z, especially knowing that you're using compression and getting this much compression, your block size is going to vary a lot. It can affect how RAID Z lays it out and mean it's a much harder to reason and predict how that's going to perform in terms of IOPS. So looking at some of the advantages of running ZFS, the first we talked a bit about was per dataset encryption. Being able to have a different encryption key and being able to put different data at rest while other data is still online can give you a lot of different controls. And I know you guys are using this at Entersekt, right?
well, our keys are generally online all the time for the data sets, but we use different keys for different types of data. I mean, I guess we probably don't have to, but having different encryption for the MariaDB binary log storage versus the actual data versus the Gcache of Galera, for example, just because they're on different devices and different data sets, we can have different keys. So why not do that? It doesn't cost anything. And one day, pointing at that might actually turn out to be helpful.
Yeah. And as we talked about before, all the maintenance operations, data verification, replacing failed media, all that can happen without needing to load the encryption keys. Although in your case, for the live database cluster, the keys are loaded all the time.
Yeah, but I can also say that when let's say we move between data, let's say I want to spin up a new cluster member. By far, the fastest way of doing that is sending the data over to a new piece of hardware, but maybe we haven't fully provisioned that hardware yet. It's not fully under all the security controls and configuration standards and everything. It's not entirely there, but I just want to be able to shift the data, or it still takes a day or three because of the sheer amounts of it. But because the key doesn't exist there, it doesn't matter. And I can do these data sets one at a time. One of them, like the binary logs, for example, I might not want to transfer at all, or at least I don't need the key over there. So, it's all these different benefits.
Yeah, I think in particular, the ability to send the data, especially if that's going to take a while, because you were talking about a petabyte of data, before the system's ready and just not load the encryption key until all the security is in place.
Yeah.
Other big advantage, obviously, is the openness and portability. The on-disk format is documented. People have made other implementations of ZFS. So even if you weren't happy with ZFS itself, if there's some other thing, you can always build the software to read the data yourself. And the fact that you can change hardware without replatforming your data, or as Eirik has, have a data set from almost 20 years ago and be able to show it has moved from, these 8 different platforms we've been through, and it's still there and working and unmodified. Not having to replatform your data is a huge advantage. And then one of the really big ones that we've only briefly touched on is the intelligent caching. So when ZFS is caching data, it can leverage that same compression it uses for disk. So the buffer cache in ZFS caches the on-disk version of the data. So if we've compressed your database 3.5 times down to 1, that means we have 3.5 times the amount of data fitting in the same amount of RAM. So, if we only have 256 gigs of RAM, but we can fit 3 times that worth of data in it, then that's also another giant savings that you have. And it's one of the cases where, while in the past, especially, the best practice was, turn caching in ZFS off for the database and let the database engine do the caching. As Eirik said, because the database is using a page size that's usually 8K for Postgres or 16K for InnoDB, the compression it can get on those pages is quite limited compared to if you're using a larger block size in ZFS. Because your data is kind of write once, then ZFS is able to get much more compression. And while it's caching won't know as much about how you're using the data, the fact that it can cache 4 times as much data in the same amount of RAM will outweigh that decision. And so it won't be the same for everyone. Other people's data isn't the same as Eric's, but for data that is like Eric's, it's kind of a no-brainer to go hard into ZFS for the caching. Did you have anything to add to that, Eric?
Yeah, I was just thinking, so we have some systems that kind of sit on that do the exchange replication streams between our physical sites, particularly one system where we have 2 separate Galeras running on the same piece of hardware. And then, of course, each of them have somewhat limited InnoDB buffer pools, and ZFS does the majority of caching, and that that actually enables it to better, schedule things for the hardware instead of each of the sort of caches running not knowing anything about the other. So we get, 1 plus 1 is a fair bit more than 2 on that system. It's actually, I'm impressed every day when I look at it and what it actually can do. So basically it coalesces replication streams from 2 different production clusters, stores that locally in 2 different sets of jails and everything, and then it passes that on to the site local servers that actually serve the applications. But it really makes sense to use the ARC for that rather than huge buffer pools in InnoDB.
Yeah, especially your use case is kind of uniquely well suited to it, but there's oftentimes that trade-off goes, sharply one way or the other.
Very much so.
We have another customer who has a database that's about 8 petabytes, or sorry, 8 terabytes. It's 8 terabytes of database, and they need to run it all in RAM. But the biggest server they can buy has 6 terabytes of RAM. And that's, a special 4-socket machine from HP just to be able to fit 6 terabytes of RAM in it. And so without some kind of compression like provided by ZFS, there's no way they could fit their 8 terabyte database in 6 terabytes of RAM. But it compresses 2 to 1 with ZFS. And so even with a small record size, so that means currently their 8 terabyte database is only taking 4 and a bit terabytes of RAM, and they actually have some headroom to keep growing. And hopefully by the time they run out of that headroom, either we can amp up the compression some more, or a system that has more than 6 terabytes of RAM is physically available to purchase, which right now it is not. And you mentioned replication. One of the nice things is ZFS can also leverage that compression for the replication. It will, during a raw replication, it will send the data in its already compressed form. So it's not even having to spend CPU time recompressing or decompressing it. It just transfers the already compressed version. And that means that when you're replicating this data, you're also saving that much bandwidth and that much time and letting you keep your backups that much closer to your RPO. And, maybe touching a little bit on Pletton's question in the chat, you can also leverage flash acceleration. Eric's lucky in his case, he's running on all NVMe, but for his backups, he's not. And so we're looking at, if we could add just a bit of NVMe for metadata and maybe some small block offload, that can really boost the performance of that hard drive-based pool without having to spend the huge amounts of money that you would have to try to make, especially backups being all NVMe doesn't seem to make sense in most cases. So summarizing what we talked about today, the first thing is, the criteria for independence are making deliberate choices, knowing why you made a choice and that it's serving your ultimate goal. Truly independent design means you're leaving your options open in the future. You're planning your exit strategy upfront and avoiding the costly mistakes or data gravity that's going to leave you locked into a bad platform because it's going to take too much effort or too much cost to get your data back out of it. You're avoiding vendor lock-in. You're not getting stuck on their support or their licensing. You're not paying per terabyte licensing. You're not stuck with paywalled features or locked to a specific brand of hardware, or some kind of forced obsolescence that's going to limit your choices in the future and keep you from moving on to a different platform. We need something that's open and portable. Open source provides the assurance that you will always be able to manage and migrate your storage, even if something changes with that software. You either have you have access to the source code as it is at any point, and with the community, there will likely be a fork that's going in the direction that you want to go. And you're maintaining control. Only you have control over your data, your hardware, and your system lifecycle, and that allows you to ensure that you decide when it's time to move on, how you move on, and you can select your own support supplier and you can control your own crypto keys. Any other closing thoughts, Eirik?
Not really. I see there are a couple of questions I would like to try and answer during this session. Yes.
So go ahead.
So can start with one from Greg earlier on, who asked how much internal expertise is required to self-host ZFS, and how readily available those people would be. I would say that it does. The majority of my time I spend on application level questions, despite also with my team of like 10 people-ish operating this production infrastructure and everything. And the important part when using ZFS, you need to try and sort of get it right when you start out, because it can be a bit hard to turn around when you have like hundreds of terabytes of data and you realize, oh, damn, I should have used mirroring, or I should have done this, that, or the other. So if you ask the right questions before you get started, you might even get that info from elsewhere, get help from elsewhere to do so. There isn't a lot that is needed day to day, but of course, but the nice thing with ZFS compared to many other storage architectures that are, powerful in the same way, is that the tools are very simple. You have two commands you have to worry about, and they're not that hard to learn the basics of. Sure, you need to spend a bit of time figuring out how do you design your pool, etc., etc. But once you get down to managing data sets or snapshots or sending, receiving, that's fairly straightforward. If you spend much of your time on the command line, especially on a Unix-like system anyway, it's not going to take you that long to get the basics done. And there's a lot of good info to be found from Klara and elsewhere about getting started with managing your Z pool. So it feels like we moved from the old days of logical volume management and Veritas backup and all these different things to a set of tools that are meant to be simple. It's almost like it's democratizing the whole storage problem by making it available to a lot more people. So finding people who already know it, still possible. You have Linux people out there who use ZFS heavily. The question is, if you find someone who's a qualified sysadmin, for example, how hard is it for them to learn what little they need to know about ZFS? Not that hard. So I would say it's not really, it's not a big factor. Running your own infrastructure in the first place is a much bigger decision than ZFS versus something else.
Yeah, exactly. And ZFS was designed 25 years ago specifically in response to the complexity of the Veritas Volume Manager. And the design goal was adding more storage to your server should be the same amount of effort as adding more RAM to your server. You plug in the additional hardware and, you know, configure it and it works. Like you're not editing config files, you're not doing long operations to resize a pool or something. You're not, there's no complexity. It's just like, oh, there's more storage now. Okay, it's available. Start using it. You're not having to, edit a lot of config files or spend a lot of time or have risk of doing something wrong and losing all your data. It's really designed to make it easier to manage your storage and make adding more storage only as complicated as adding more RAM. One more question here from Martin asks about key management and kind of managing and provisioning encryption keys for the storage servers. There's different options there. One of the nice things is ZFS, in addition to being able to use, a manually entered passphrase or a key file that you can manage however you like, it also has support for getting the keys from basically an API. So something we've implemented for another customer is, when the storage server boots up, it sends some data via an API from its TPM to prove that it's running the authorized software and nothing else, measured boot and proving that, this machine hasn't been compromised to an external server that then says, okay, I've verified you're booting a trusted build of our software. Okay, here's the key to decrypt your data instead of it having to live on the machine or on, physical media or whatever. But, for some places, kind of like Eric was talking about, the encryption keys on maybe could be a separate device. And then, oh, we need to move this machine from one data center to the other. And it's maybe going to be at sometimes out of our hands while it's in transit. We remove the device that contains the keys, and then we can ship the server. It's just an encrypted wad of gibberish until it arrives. We rack it up at the other side and plug back in that encryption key.
So I can add a little bit to that. We have some ugly hacks in place for the encryption part that on some of our systems, the encryption keys are actually wrapped in PGP keys that where the private key sits on a YubiKey, and during boot up, the YubiKey is interrogated and it decrypts that key to a FIFO buffer on a different device, which then ZFS reads from the one time it needs to read it to actually mount the pool or the data set. So we can yank that YubiKey out after the system has booted. We can take that YubiKey to a different system where we want to restore the data from that crashed system or whatever it is, and we don't need to ship the key around in plain text or anything like that. So you have a lot of options. That might not be an optimal one. Don't try this at home, etc. But it's possible.
Yeah. So thank you so much for joining us, and make sure you tune in next time for our next webinar. I'll be joined by Chris Moore from TrueNAS talking about cost-efficient storage with fast dedupe. So that'll be April 29th at 11 a.m. Eastern or 8 a.m. Pacific. So definitely join us for that. You go to the QR code for that is there on the screen. And then, of course, much of what we talked about today is our ZFS deployment service, especially in environments where you're worried about compliance, security, or sovereignty. Our design service is exactly about that. It's helping you, as Eric said, make those early decisions that are hard to change after the fact and make sure you're picking the right hardware, laying it out the right way, and setting yourself up for long-term success when you're deploying ZFS. You can avoid those common pitfalls and make sure that you're not going to have problems that show up a couple months after you deploy this. And our design and implementation service not only helps you kind of pick out the hardware and design it and get this online, but also integrate it with the rest of your systems and end up with a fully working and very powerful storage system that you'll be able to maintain and migrate yourself. And as always, you have the choice of support vendor, although we work very hard to make sure you choose us as that support vendor. All right. I think that wraps up today's session. Thank you so much for joining us. I hope to give you a clear and practical view of how ZFS supports data sovereignty and operational independence, and how you can build long-term infrastructure control. As we saw today, avoiding vendor lock-in and maintaining control over your storage stack isn't just a technical decision, it's an architectural and business decision that has impacts on security, compliance, and costs over time. All right. Thanks, everyone, so much for joining.
Thank you.